This is the mission 54, organized by Space Analog Station of Marte. And today we have the presentation of Elif Keve. Okay, Elif, you are welcome to start your presentation. Now I am let you as a host of the meeting, and then you can share your screen. Okay.
Yeah. Okay. Okay, I will share my screen now. Okay. Hello everyone, I am Elif Keve from Turkey. I graduated from architecture, and after my graduation I decided to expert in space architecture, and I'm planning to do my master program in this field, and I'm waiting for universities to be accepted and continue my education. For now, studying about space architecture at home and trying to deal with some space programs. And today I will have a presentation about MOXIE. Before starting with MOXIE, I want to make a brief history of space. As you know that in the past we had a mission for the moon. It's Apollo mission. About 9 Apollo mission had successfully flight, but 6 of them could successfully launch the moon, and 12 people could walk on the moon. But after it was around 1972. After 1972, we didn't do any mission to moon. But after that, people plan to move to Mars. But before going to Mars, we have to do all the missions we wanted to on Mars firstly on Moon, because as you see on the chart, from the Earth to Mars, it takes around 6-month journey and passing through a lot of radiation and hazards of space. So we have to try it from Earth to Moon. It takes three days, and human psychology is fine for this journey, but not for the Mars. So after Apollo mission, Artemis program had designed. So Artemis program has 2 phases. First phase is from Earth to Moon, and the second phase is from Earth to Mars. Levels, let's say from Earth to Moon, first phase has Artemis 1, 2, 3, and 4, and in each of them they will try to make a base of Moon for let's say analyze. Let's say it will be kind of analoging Mars mission there firstly to check the human psychology, and after phase 2 we will move to Mars with the same program. So we still in this time period we have some project that we will make the program make human psychology or prepare the base. And when we check the Mars atmosphere, I found 2 different charts. I will show 2 of them to make you clarify the right decision. In Mars atmosphere, as we see here, carbon dioxide has 95%, which is the most gas which we have on Mars, and the other rest of it is written here. And I found this chart as well. It's from NASA source. Maybe that will be more reliable. And again, of course, carbon dioxide is the most we have here, nitrogen, and then argon. As we see here, the nitrogen is little less than argon. I don't know which one will be true. Perhaps this one, because from the NASA source. And oxygen a little bit, and carbon monoxide, water vapor. Okay, so then we, as you know, that in 2020 we had Mars Perseverance to Mars, and it's still on the way. Perhaps that will land on February 2021. And on this rover, on this mission, we had a helicopter, a rover, and so where is the MOXIE? Before of saying where is the MOXIE, I want to tell you what is the MOXIE. MOXIE is an abbreviation of Mars Oxygen ISRU experiment. ISRU itself is Institute Resource Utilization. I saw a meaning in dictionary about MOXIE, but it's perhaps not about the MOXIE that we work on. It says that ability to face difficulty with spirit and courage. And MOXIE is a short, snappy name for a tool that helps lead to human footprint on Mars. It helps humans explore Mars by making oxygen. It works in place on the red planet as in experiment. So when we are think about the Mars, we see 2 main problems. One is, and one of it is human breathing, and the second one is if humans go there, how they will come back to the Earth. For these 2 issues, we need oxygen on the atmosphere. So MOXIE project will save human from these 2 problems. The owner of project, Michel Hack, says that human exploration of Mars will be a seminal event for the next generation, the same way to the moon landing mission was for my generation. And I want to show you here where is the MOXIE. And as you see, the rover, complete rover, and as you see with the flags, all the pieces of this rover made by other countries. And we see here the MOXIE itself. But what will MOXIE do on Mars? As we know that it will, let's say, convert carbon dioxide to oxygen. But out of this, we need to know a little more details. The MOXIE, which is on the way to go to Mars now, it's will be produced in the biggest scale in the future. And For this one, that's the only way. It produces 6 on 10 gram of oxygen per hour. It's like a small tree, like here. It's producing 50% of what we breathe. And also, we can say that that three missions, one of it is characterization and then operation and experimentation on the Mars surface. We needed to know 5 important things about MOXIE. As we know, the first one is producing oxygen, as the 95.6% of Mars atmosphere is carbon dioxide. And the second thing, MOXIE is a test model for now. So in the future, as I said, that will be produced with the biggest scale of it. And MOXIE helps future exploration. How? As we said, that it will help human to breathe, and then it will make human to come back to the home, the pale blue dot, our home, with a lift off, because we cannot make a lift off from Mars to Earth without oxygen. And humankind didn't want to carry like pressed oxygen from Earth to the Mars, making an extra load, and it will be perhaps make the mission more expensive. So MOXIE will make the mission cheaper and easier. And the fourth one, MOXIE breathes like a tree. As we know, on the Earth there are trees, forests. They are working like MOXIE, and they're producing oxygen for us. And the last one is homemade on Mars. Homemade liquid oxygen on Mars could supply more than 3/4 of the propellant humans need for exploration on the red planet. And here we can see a little more detail of inner of MOXIE. I want to talk about especially 2 of these piece of MOXIE. As you see here, sensor panel, but here is screw pump that suck the air into the machine to produce some oxygen from carbon dioxide, and it's exactly works in SOXY part in the yellow one, and the pink one is scroll pump that sucks the carbon dioxide or the air. Okay, when I put MOXIE together, I see these details. There's the yellow one here. It's screw pump that pumps the air from one way. It takes the air and exhausts the oxygen, taking carbon dioxide and work on it and give back the oxygen. And this one, this is SOXY and this is screw. So this is screw and this is SOXY. Create the oxygen. Okay, I will give detail more about these two stuff, and it's next to each other here. Compressor, we say compressor for screw, and it's here. Here you can see a lot of details of each names of the component in the MOXIE. And okay, maybe it will be a little difficult to understand. I will give the simplest explanation how it works. Let's check it. Okay, here is screw pump. It's sucking the air and then sending it to SOXY, and all the reaction happens here. And we have the carbon monoxide and the oxygen here, and in different ways it goes away. Like, let's see here. Here it takes carbon dioxide here, like you can check here, and working on SOXY here, and taking out the carbon monoxide, exhaust, and oxygen. And how is it work inside of SOXY? Let's check this one. Cathode, cathode and anode on chemistry lessons maybe. It takes the molecules pieces from the negative and positive loads to right to left side, and in the way we can have oxygen and the carbon monoxide in different pieces. And maybe this is the simplest diagram of understanding how it works. As you see here, it taking air, okay, and then here with this it's screw pump. Screw pump is sucking the air, and then here it takes cohesion and compression. With the compression itself, it's taking it into this solid oxide electrolysis, which we said it's SOXY. It's producing oxygen and taking it away for composition measurement and exhaust outside. Okay, so here screw pump, and here is SOXY, and in the previous one here is screw pump, and here is SOXY. So checking first the screw pump that is sucking the air. Okay, and I want to give a little more detail on this machine about this component. There is a housing here, but in this part there is a part that attached directly to housing, and this is moving screw, and can polaris limit moving screw movement. And okay, then SOXY. SOXY is solid oxide electrolysis. Solid oxide electrolysis has two sides that has anode and cathode. So when we take air into it after a screw pump, it will make a molecule of carbon dioxide into oxygen and carbon monoxide, and exhausting outside. I can give the simplest reaction how it works. Like to maybe that can seem a little more effort for a little oxygen, because MOXIE itself gives exhausts almost half of the carbon monoxide it takes in, as we see here. As I told you that cathode side and anode side, one is taking a part of a molecule and other one taking another molecule part. So finally, it takes, we can simplify it with 2 molecules of carbon dioxide, and it will produce 2 carbon monoxide plus 1 oxygen. As I told you that whatever MOXIE do in work, it will produce half of it. Okay, so as I mentioned initially, the Mars 2020 and Perseverance, we have this small size MOXIE, but in the future we will have full scale MOXIE, and will make it easier to have more oxygen before human land on Mars. And then a little more about full scale here. After that, we have some information here about MOXIE itself. Firstly, I want to talk about what limits oxygen production. We can say, okay, MOXIE capability is 20 grams per hour, and a power supply capability, it limits production 12 kilogram per hour. And this kind of each component of MOXIE has make limitation on machine to have less oxygen production. And third of it is landing site. Its elevation determines inlet gas pressure, and pump capability makes it 10 gram per hour, and safe operation margin, what fraction of it carbon dioxide can we use. Season and time of day can affect of production oxygen also. Here is a small chart about utilization of producing oxygen, how it affects how it's giving away the exhaust oxygen. I want to show you the previous picture here. We take oxygen here, the air here, and take away the carbon monoxide and oxygen. But as much as we have carbon dioxide or everything, and having higher pressure here, we can have a better result, as you see on this chart. As much as we have more pressure of the SOXY and having more air into the machine, we can have a higher utilization. But still, as I told you on this part, we still have limitation for production oxygen. These are like the air situation, like say in this dust itself, it's a problem there. Summer nights and fall days, it's make a different effects on production oxygen. Okay, then we can talk about how the power of MOXIE goes, because the power of itself is not only for producing oxygen, but still we need it for the other components of machine itself. 60 watt will be used for SOXY, and 110 will be used for pumping, screw pump, for sucking the air into it. 72 is for stock heaters, and for sensors is 9, and electronics and mostly this conversion is 67. So it's not 100%. So we can't say 100% it works for only producing oxygen itself. Okay, finally, I want to ask you questions who listen to me, what you have learned until now. So maybe we can write this part together. I have written something here, and the rest of it you can help me to add. Do you hear me?
Yes.
Okay, maybe I can firstly tell you about the things I have learned from this presentation. One is SOXY works great, but it is still much an artistic thing. So in the future, we plan to make it more efficient. And the second one is pumping takes more than half the resource. As I show you on the reaction, we take, let's say, 2 molecules of carbon dioxide, and it gives 1 carbon oxygen. It's a reaction, but still, not only that, but also, as I told you on the chart of energy, here a lot of energy goes for other parts, so it's not giving a very high percentage of benefit of oxygen production. And third one, it's hard to compress, insulate, and shake at the same time. Maybe this thing should be worked on. And a little dust, maybe you have seen that Mars surface detail, they have some pictures that shows the dust itself, and this dust with the climate of it, it's affecting MOXIE work better. And then, what do you want to add here? What you have learned from this presentation so far? Do you want me to add something? If not, I have already finished my presentation.
Let's see here. Pallav has a comment.
Yeah.
Could you please explain more how reason will impact oxygen production? First, it needs to scale up definitely. Okay, she's also commenting the chat of the group.
Yeah, I want to see the chat. Can I stop sharing the screen because I have finished my presentation?
Yeah.
These are the references and my all contact. If you like, you can contact me in any way. And I stop share.